Okay, now we talk about equation 12. Consider the system of equations, right? X minus z equal to k, 2x plus 3y minus z equal to negative k, and x plus 3 bracket 1 minus k, y minus kz equals 0. Okay, this one is called augmented matrix, right? Now equations, you need to use a Gaussian elimination to show that this can be written as follows. This method we call this one is called Gaussian elimination. Okay, the Gaussian elimination, there are three concepts. One, remember row and row can swap. You can swap row and row. Two, row, any row can times any constant you like it. Three, any row can times a constant and plus or minus another row times another constant. Okay, you just remember like this one. So be careful. Row plus or minus constant is not allowed, please. 5. Row times or divide any row is not allowed too, okay? Okay. Now, I try to show this one. My method, I think, will be a little different ETA textbook, but the same concept. You can reference 1, 0, negative 1, 0, 3, 1, 0, 0, 0, k, negative 3k. Oh, original one should be 1. Sorry. That's the result. One, 0, negative 1. K, negative k. 2, 3, negative 1. 1, 3, 1 minus k, negative k, 0. Row 1, row 2, row 3. Okay. But first, I will do row 2 minus 2 row 1 because I want to make here become 0, right? And then make here become 0, and then here become 0 too, right? I will keep this part, the diagonal is a number. Okay, the first step I will do row 2 minus row 1. And I will write down in the right side like that. 2, 3, negative 1, negative k. So minus row 1, I minus 2 row 1, okay? Minus 2 row 1. So we make row 1 times 2. Write down here 2, 0, negative 2, 2k. Okay, you can do it. 2 minus 2 is 0, 3 minus 0 is 3, negative 1 minus negative 2 becomes negative 1 plus 2 is 1. Negative k minus 2k become negative 3k. Then I rewrite it, alright. I get 1, 0, negative 1. Okay. 0. So row 2 now you become 0, 3, right? 1, negative 3k. Okay, now I will do row 3. I make here become 0, so I make row 3 minus row 1. Row 1. So 1 minus 1, 0, 3 times 1 minus k times minus 0. So you still become negative k minus negative 1 become negative k plus 1. 0 minus k, negative k. So I get new matrix will be one, 0, negative 1. Okay. 0, 3, 1, negative 3k. 0, 3, bracket 1 minus k, negative k plus 1, negative k. Okay, now I will make R3 divided by 1 minus k. Right. So what happened? R3 divided by 1 minus k. So this one we don't need to do the row addition and subtraction. So you can just you can get 1, 0, negative 1, k, negative 3k, 1, 3, 0. So R3, row 3 divided by 1 minus k here is still 0. Here become 1, right? Divided by 1 minus k. Oh, here becomes 3, right? So here become negative x, negative k plus 1 over 1 minus k. 1 minus k, negative k plus 1. Oh, here should be 1. Should become 1, right? And here become negative k divided by 1 minus k. Okay, now I want to make here become 0. So I do what? Just minus row 2. So we can do row 3 minus row 2. So row 3, 0, 3, 1, negative k, 1 minus k, minus row 2, 0, 3, 1. Negative 3k, so I get 0, 0, 0. Okay, here is negative k over 1 minus k minus negative 3k become plus 3k equal to 1 minus k, negative k plus 3k k, right? So become negative k plus 3k minus 3k squared over 1 minus k. Become 2k minus 3k squared over 1 minus k. You factorize, become k 2 minus 3k over 1 minus k. I think nearly get answer, right? 1, 0, negative 1, k, 0, 3, 1, negative 3k, 0, 0, 0, k, 2 minus 3k over 1 minus k. Okay. Yes. Oh, here they don't have they don't need to factorize, so I just rewrite it. Okay. Okay, now we talk about B. For which values of k does the system have solutions? Have solution. What does it mean? Have solution. Maybe it's unique solution, right? Or maybe it's have solutions. It doesn't matter. It's solutions. Solutions. What does it mean? Solutions. It mean infinite solution. We have 3 scenarios, right? We go here to refute it. Using row operations to solve the 3 times 3 system. If you have one simultaneous equation like this one, if you already learn a vector, do you find out this one like a 3 plane, right? Okay, now we use augmented. We set up augmented matrix form and do the row operation. Remember here, finally we get here. And then we discuss h and I. If h is not 0, if h is not 0, so it means here you will get it. Because for this augmented matrix, right? Here it means x, right? Y, z. So this one it means x, 0x plus 0y plus hz equal to I. So if h is not 0, what does it mean? It means hz equal to I. So you get z equal to I over h, right? Okay, that's it means unique solution. So if h is not 0, if this one is not 0, you mean you have a unique solution, only one solution. Okay, so if that's the first scenario. Second scenario, if h equals 0, here equals 0, what does it mean? It means no solution. Okay, if h is 0 but I is not 0, okay, for example 0, 0, 0, 3, so it means no solution. Okay, we call this one called inconsistent. Or how about if here is 0, here is 0? So if h equals 0, I is 0, these two students always confused, remember? 2 and 3, okay. When h equals 0, I is not 0, is no solution. h equals 0, I is 0, that's the infinity solution. Infinity solution, okay? You mean many solution. So the question asks us, have infinity solution, okay? So what does it mean? It means h equals 0, I equals 0. Therefore, we need to go back to the augmenting matrix. Here, 2k minus 3k squared over 1 minus k should be equal to 0. So if 2k minus 3k squared over 1 minus k equals 0, denominator cannot be 0. Right? So it means 2k minus 3k squared equals 0. K times 2 minus 3k equals 0. Therefore, k equals 0 or 2 over 3. Okay. C. Determine the solution. Determine the solution of the equation for the non-zero value of k. Find C. So we need to find the equation. So we write down this one. So it means x minus z equal to in C, right? Find the solutions. So it means when k equal to 2 over 3, right? Okay, suppose k equal to 2 over 3. So what do we get? It means x minus z equal to 2 over 3. Another one is 3y plus z. 3y plus z equal to 3k. So 3y plus z equal to -3k equal -3 times 2 over 3. So we get what? So we get, you can make a z equal to, make z equal to lambda, alright? So we get x minus lambda equal to 2 over 3, 3y plus lambda equal to 82. So you get it. X equal to lambda plus 2 over 3, y equal to -2 minus lambda over 3. So you can get it now, we get x, y, z equal to, because he only talk about non-zero k, so we only use k equal -2 over 3. No, k equal 2 over 3. So x we get a lambda plus 2 over 3. Y is -2 over 3 minus lambda over 3. They equal lambda. Okay.